Hey, Thomas Core here. Today I'm here to answer the question, why are there 12 notes in an octave? So if we want to choose how many notes to divide the octave into, we first have to decide which notes are important enough to include. For that, we'll look at the harmonic series. When a sound is produced, its waves hit your ear at regular intervals. That rate is called frequency, or the number of wave cycles occurring every second. Frequency determines how high or low a note sounds. Say we play this A with a frequency of 110 Hz. Not only do we hear that tone, but also all of the whole number multiples of that frequency. This is the first, or fundamental, of the series. So 110 Hz times 2 is 220, an octave, with a 2 to 1 ratio to the note before it. Its wavelength is unsurprisingly half that of the note before it, too. Times 3 is 330, an interval of a fifth with a 3 to 2 ratio. Times 4 we get a fourth with a 4 to 3 ratio, then a major third with a 5 to 4 ratio, and a minor third with a 6 to 5 ratio. These ratios are really nice numbers, and your brain knows that these are really nice numbers so that they sound nice or constant to you. They sound so good, in fact, that these first harmonics have become an essential part of Western music. When we divide the octave, we wanted to be sure that we could play these intervals as closely as possible. Currently, Western music uses a tuning system called equal temperament, in which the ratio between any adjacent notes is constant. Okay, math time. Because multiplying the frequency by 2 gives us an octave, and there are 12 notes in an octave, the frequency of any note is the 12th root of 2, or 1.059463 times the frequency of the note. But wait, you bewail, that number is irrational, not great for making whole number ratios with. Let's hold on to this idea. We can also write a geometric sequence for this relationship, where the frequency of any note at a distance above the first, in this case 8-2, times the 12th root of 2, set to the power of how many notes above the fundamental you are minus 1, then multiplied by the fundamental. Going into this, we have to accept that no matter how many notes we squeeze inside an octave, everything but the octaves will always be a little off. So why 12 notes? Well, if we use our equation, we can see that the most important interval, the octave, works perfectly. Then the fifth is less than 1 hertz off. Don't worry if you couldn't tell the difference. Most people can't. Then the fourth is really close too. By the time we get to the minor third, however, you might start to hear some difference. But wouldn't choosing to divide the octave into more notes improve our accuracy? You're right, 19, 41, and 53 put our 12-note system to shame. By guessing and checking on our calculator, we can see that the 53-note octave replicates the perfect fifth, well, almost perfectly. The thing is, we start hitting the upper limit where it becomes pretty cumbersome to shove so many notes into an octave. So there you go. 12 notes is a bit of a compromise between nice numbers and size. We're almost done here, so I just want to leave you with one final idea. Every song we've ever heard is just a different combination of the same dozen tones, and so we've grown accustomed to them. The relationships may be slightly off, but while our brain searches for simplicity, it also searches for familiarity. Even if we decided we needed to change, 12 notes is a hard habit to break.